Hello, hello. Um, this is an odd chapter, and as you can see from the syllabus, it's divided in two, in part because it deals with things that are dear to my heart and some technology that we've already seen, and I wanted to review. Um, so this is part one. It will focus on Guthrie, who's early in chapter seven. And we'll take a quick look at chapter seven's view of Guthrie and then get to my lecture. And why do I like this? Guthrie is often, I spoke to one of my students from over a decade ago about whether she remembered Guthrie, and she said, absolutely not, no idea. And I didn't used to lecture about Guthrie back in the day, but a few spins ago, it struck me that Guthrie got some things right, and he doesn't get much credit. And I kind of liked, get ready for it, the math. And he comes at this from a very different perspective than we're used to. So let's take a quick look at what it says here. Um, it says that the the chapter turns an important corner from Pavlovian SO uh, to response learning and RO learning, instrumental or operant conditioning. And the Skinner box is going to be an issue, and we'll be talking about that technology in a bit after Guthrie. And as you can see, the book is always going back and forth and back and forth. And one reason for that is that it makes you review older stuff. And one issue that we'll address in the Guthrie section is the difference between massed practiced and spaced practice. The book is desperately trying to get you to relearn material as it goes through new material, spacing it out. Mass practice, another term for that is cramming. Oh my God, I have a quiz tomorrow, I have an exam tomorrow, I got to learn this stuff, and you cram it. And the literature is totally clear that if you're in college to learn material, that's not the way to do it. It may serve you well in terms of grades, particularly if there's no cumulative final in the course. Of course, this course does have a cumulative final. But if you're here to learn things, cramming is not the way to go. And we'll see some of that in Guthrie, in my lecture on Guthrie, not the textbooks. Um, and he's putting it in perspective and reinforcement versus contiguity theory. Now, uh, contiguity has not really been an issue very much in this textbook. And I must admit, it's not typically a huge deal in modern learning theory, but arguably it could be. And there we go back to chapter one and Thorndike and puzzle boxes and reinforcement, and we'll come back to that. And there's the bane of my existence, Clark Hull. In graduate school, every time we did with Hull, I got stressed. I never did like his math. And there's our hero of the day, Edwin Guthrie. Now, Guthrie, did his stuff in 1935, which is quite a while ago. Um, he overlapped with B.F. Skinner, but they had very different theories. Um, Guthrie, and you need to know this phrase, Guthrie was an all or nothing, let me repeat, Guthrie was an all or nothing uh, temporal contiguity theorist. Um, Guthrie was an all or nothing temporal contiguity theorist. In other words, he didn't think learning occurred gradually. You just got it, all or nothing. Another way of saying all or nothing is one trial. And he thought all you had to do to have learning occur was two things occurring contiguously in time together. Um, and this should sound pretty unfamiliar to you because we haven't done anything like it um, this semester. And there we go. Guthrie's contiguity approach strikes many people as rather strange. Right. Now, a key to his thinking was this concept of stimulus elements. You're experiencing the world right now, and you're experiencing stimulus elements right now, but there's more stimulus elements in total than there are in your experience right now. And that's the key to Guthrie's theory turning out to be really, really quite clever. And here's a graphic down the bottom of the page. So the graphic is using gold or mustard balls and blue balls. I use white balls to indicate that they're empty, and black balls to indicate that they're full. Remember, Guthrie is all or nothing. There's no such thing as, like in politics, a purple state. There's part red and part blue. You're either red or you're blue. There's no mixing. Now in trial one, you come into trial one and all your little balls are empty. In my world, they'd all be white. But on trial one, you experience that circle, and the circle cuts through some circles. Ignore that. You experience that circle, and then you have trial one, and trial one, all or nothing temporal contiguity theorist, all the balls in that circle in one trial, bam, they are all learned perfectly, nothing gradual. And then time passes and things drift around, and now you have trial two, which has some balls from trial one, but most balls are not there, and so on and so on and so on. And across trials, eventually your focus shifts around enough that all the balls, that's trial 16, will eventually become, in Guthrie's world, blue, in my world, black. And that's about all I want to do here. Now, this may make your blood run cold because a lot of you did not get Rescorla Wagner. Let's go back to chapter 4. Remember this figure. And that does not look like all or nothing temporal contiguity. It looks like a gradual learning function. Your associative strength, V, which is really the sum of delta V's. On trial one, just like Guthrie, all your balls are mustard, and you have no associative strength. But after trial one, you have a 0.2, and then on the next trial, you don't have 0.4, you have less than 0.2, and so on. And we went through that to some great extent. And to me, it makes sense. I recommend that you review it. And this has a lambda and asymptote of 1, and I'll stick with that. Although on the next page, they will sample different lambdas. Okay, and there's our formula. delta V, change in V, equals alpha beta, which I simplified to kappa. The alpha beta deal with CS and US, and lambda minus the existing V. So of course on trial one, the existing V is 0. So the difference between lambda and 0, 1 and 0 is 1. And so the only unknown is the alpha beta. And when we look at this, we deduce that the alpha beta, in my world kappa, because I simplify it, is 0.2. And that's Rescorla-Wagner. Delta V equals alpha beta times the quantity, lambda minus V. Your text author loves it. I'm still a fan of it. You really have to come to grips with it. And as I predicted when I gave this lecture, it feels like long ago, you guys are having trouble differentiating between delta V, which is change in V, and V, which is really the sum of delta V's. So in this figure, the y-axis is your associative strength V, which is the sum of delta V's. And then each trial has its own delta V. Now on the next page, they were talking about how surprising is it, and that's of course lambda minus V. And there's a lambda of 1, which we've already dealt with. And then there's a lambda of 2, which we didn't spend much time with, but the math makes sense. And then the next figure has a lambda of 1, but different alphas, and you can see you get different shaped functions. And that's all nice. It's very cute. Definitely review it. You have to know Rescorla-Wagner. Okay. So delta V equals alpha beta times the quantity lambda minus sum of V. And sum of V is what's on the y-axis. So that was fun back in chapter 4. And it deals with surprisingness. Rescorla-Wagner was not a Guthrie type theory with a contiguity theorist, all or nothing. Very different, very, very different. Arguably, there's an element of cognition here because of surprise. Okay. Have I given this lecture before? Why, yes, I have. And now we're going to spend quality time with a spreadsheet I have. Take a deep breath, stay calm, read each column. We're assuming we are putting 20 balls in our head each trial. 20 balls, 20. And we're doing spaced trials. Now, what does that mean? It means there's so much time between trials that it's sort of like a bingo game where the balls you originally drew go back in the mixer and are all jumbled up again. So between trials, the original 20 balls and the 80, I didn't say that yet, but there are 80 other balls, are all scrambled up. So in this model, each time you look at the world, you have an all or nothing temporal contiguity experience. There are 20 balls in your head out of 100 balls in the world. I say up in heaven here. So black balls, remember, are learned balls. They're absolutely full, all or nothing, totally black, no white, no gray. And at the beginning of trial 1, you of course have no black balls in your head because you sampled, remember the Guthrie image, you sampled 20 balls from a world that had only empty white balls. So you went into that trial with 0 black balls. But because of trial 1, all of those, temporal contiguity, all or nothing, all of those balls became perfectly learned, totally, absolutely learned. So on trial 1, we jumped from having 0 black balls total to 20 black balls total. And in your brain, column 2, you went from having 20 white balls because you knew nothing to having no white balls because all of them are black. And on that trial, you created 20 out of 100, 20 new black balls. And the fourth column, E column, proportion of black balls in your head at the start of the trial. Of course, you had 0, and therefore your response strength was 0. Your sum of V was 0 because you had nothing. Now, at the beginning of the trial, you had 0 black balls in heaven and 0 black balls after the trial. Why aren't there 20 black balls? Because that's heaven. That's not your head. The 20 black balls are in your head because time hasn't passed and the ping pong ball machine hasn't mixed them up. Now time passes, and that will change. Of course, you have 80 white balls in heaven because they haven't mixed. So at the beginning of the first trial, you had 0 out of 100 balls black or learned, contiguity, all or nothing, a response strength of 0. But after the balls scramble, you have 20 out of 100 that are learned, or 0.2. Now, 0.2 should ring a bell because if you go back to chapter 4, whoa, oh no, saving, so what's happening? Oh, it's over here. If you go back to our friend chapter 4, and the first figure that we started with, there's 0.2, just like we're Skorla Wagner, alpha beta 0.2, but here it's not alpha beta. It's the size of that window that you view the world with. In my case, 20 balls, so the math would work correctly. Okay, all right, just take a few seconds and think about this. We are trying to generate this figure, the classic incremental learning curve, negatively accelerated, where at first you learn rapidly and then you slow down, and negatively accelerated. How do you explain that if you're Guthrie, where it's all or nothing, temporal contiguity? Well, we got the 0.2, so let's see if we can get any more. Where's my, there we go. Okay. All right, now you got up in heaven, all the balls. But now you're going to do trial 2, which means you're going to randomly sample 20 of those 100 balls. Now, 20% of the balls, 20 out of 100, are black. So when you sample 20 new balls, by chance, you will get, we are assuming, some black balls based on trial 1. So on trial 2, we're going to assume that we're going to get 4 black balls out of 20, 4 out of 20. And if 4 out of 20 are black, 16 out of 20 are white. And then we're going to run trial 2. Now in trial 2, all the balls in your head, not in heaven, but in your head, are going to turn black. Now 4 of them are already black and they can't get blacker, so we could ignore them. But 16 were white, and now they are just as black as the original 4. So now you have 20 black balls in your head that are 20 balls in your head that are black. and of course, no white balls. And how many new black balls came into existence? This is a lot like thinking about delta V. On the first trial, we added 20. On the second trial, we're not adding 20, we're adding 16. And in heaven, again, because what's in heaven is not in your head, nothing changes. But once what's in your head, which is 16 new balls, you go from 20 out of 100 black balls to 36 out of 100 black balls. And now we get a sum of V, according to Rescorla-Wagner, of 0.36. Let's go back to chapter 4. And, oh, geez, 0.36. There it is. That's the next trial. When I don't know, I was probably 60 before I figured this out. This, to me, was like magic. How did Guthrie do this? He must have been quite clever. I've never read any original Guthrie, but I respect the heck out of him. And he was able to explain, Rescorla-Wagner and surprising and all those Greek letters and math very simply with these all or nothing things. Okay, now we're not going to spend much time on trials 3 and 4, but I'll leave them up here. So on trial 3, in your head, we're going to bring down about seven black balls from the ping pong balls that are mixing in your head. Remember, there are 36 out of 100. Bring down 7, which means the 13 are white. Because of trial 3, the black balls don't change. The white balls change from white to black, and you add 13 black balls. So you added 20, you added 16, you added 13, and the proportion of black balls in head at the start. Yeah, okay, so that I'm not spending much time on that, but you can look at that and think about it. And again, what's in heaven is not in your head, and therefore those balls aren't changing. But when you add the 13 balls to what was true after trial 2, you end up with 49 out of 100 balls are black, which is roughly 50%, 0.49. So when you run your fourth trial, you have 10 black balls in your head, 10 white balls in your head. You run the trial all or nothing. The white balls turn black. You add 10. So across the first 4 trials, 20, 16, 13, 10. And once those go, rejoin everybody in heaven. 59 out of 100 balls are black. And therefore, your overall response strength after 4 trials is 0.59. Now, 0.59, isn't overly amazing, but it's not bad. And now we'll assume you've had your quiz, you've had your test, and now time passes. And of course, we've been let time passing between all these trials. And now you take your final. And on your final, you draw down 12 black balls, 8 white balls, because you're always doing 20. And you get about 60% on the final, which is not great, I know, but it's 60%. So there's 4 trials spaced learning. And the spacing here means that all the balls in your head in any trial get to mix with those in heaven between trials. I'm going to let this sit here for a little bit so you can let it wash over you. Very significantly, new black balls, which we don't talk about in the final, although the final will cause learning too. 20, 16, 13, 10, and that looks a heck of a lot like this figure from chapter 4. So Guthrie, with an all or nothing view of learning, no gray, all or nothing, no reinforcement, no surprise, nothing cognitive or creative. He gets a negatively accelerated learning curve, negatively accelerated because 2016, 13, 10, it's negatively accelerating. With each trial, you learn less. And on the final, you get 59% correct, which isn't too bad. Now, suppose you're not smart enough, wise enough, I mean, to study using space trials. In other words, you cram. And with cramming, you look at something, you look at something, you look at something, and the balls in your head don't get a chance to go back up to heaven. So when you look at something over and over, you think you know it really well because the balls in your head stay stable. And therefore, there are a bunch of black ones. And you do seem to know it. And actually, on a quiz, you might do pretty well. But that won't be so true on the final, as we will see. Okay. So here we are sticking with 20 balls in your head, but we're only allowing 10 balls per trial to escape. 10 balls. So trial 1 is the same. You end up picking up 20 balls because you have 20 balls in your head. All of them turn black, 20 balls. And of course, now things get weird because of those 20 balls, only 10 get to go up to heaven. Therefore, your number of balls in heaven to sample for trial 2 is only 0.1, and you bring back 20 balls, 1 from heaven. No, you have 20 balls in your head, 1 from heaven, and 10 that were already there from trial 1. So those 10 from trial 1 were already black, and the 1 from heaven is black because it's a random selection. And therefore, you only have 9 balls in your head that are white. So on trial 2, all the balls in your head become black, as they always do. But look at what you've gained by that study session. In the original design with space practice, on trial 2, you picked up 16 balls. But here, because you're cramming and you're just looking at the same material over and over, you only pick up 9. And of course, you've got 20 balls in your head, only 10 of them can go up to heaven. And on the next trial, you bring down 2 from heaven, plus the 10 in your head, for a total of 12, meaning you have 8 balls in your head that are white, which means on the third trial, you pick up 8 black balls, as opposed to with space practicing 13. So you can see the trend here. You start off with 20, but you don't go 16, 13. You go 29, 8. And then of the 20 balls in your head, 10 of them go up to heaven. And for the fourth trial, you randomly select and you get 3 black balls from heaven, plus the 10 in your head that are already black for 13, which means on the third trial, you only get 7 black balls. And so at the end of these 4 trials, you only have 44 out of 100 balls in heaven and head black for 0.44. And when you come in for your final with space practice, you had 12 black, 9 white, 8 white, With mass practicing, because you crammed, even though you might have gotten good grades on your quizzes, you are destroyed on the final. And you only get 45% correct, which 44%. Okay, so let's remain calm here. You're going to have to describe this process. You're not going to have to do, well, you may have to do, trial 1 to trial 2 for masked versus spaced. So the only difference between masked and spaced, to review, is with spaced trials, the ping pong balls get to truly randomly bounce around. And when you run trial 2, all the balls are in heaven, and all the 20 balls from trial 1 are in heaven, and you randomly select, and you end up with 4 of 20 being black. Now, with the masked practice, you restudy your material so quickly, you just looked at it. And because you just looked at it, that look is still in your head. And yes, it's learned, but there's still all those balls up there in heaven. And on trial 2, you pick one ball from heaven, 10 trapped in your head. You do quite well on trial 2, but you only learn 9 new black balls. So if the faculty member is unwise enough to not have comprehensive finals, it may arguably be that cramming will get you better grades. But if you have a comprehensive final, I can't tell you how many students have had relatively good grades during the semester, and they walk into the final and they take the final and they are destroyed, and they are totally surprised. They have no clue how they could do so well on the quizzes and then get destroyed in the final. And the reason is they crammed. And cramming can be good short term. In fact, I'm not saying not to cram right before a quiz. It will probably improve your performance. But if all you do is cram, you're not going to generate very robust learning. And you're not going to get your money's worth out of a class. You're not going to learn a lot of material. There are countless studies on spaced versus massed studying. There is no doubt that spacing your studying out will help. So I know we're doing weekly quizzes and you probably cram for the quiz and it's open book, but the final is going to be a beast. It's huge. It's the whole book. It'll be open book again. But if you really haven't learned much from these quizzes because you've been cramming, you're going to be sitting here on this page with 0.44 as opposed to on this page with 0.59. So I do this lecture every year. I know it can be confusing. You have to go back and look at Rescorla-Wagner and the negatively accelerated learning curve that's common in learning and try to put that together with Guthrie's wisdom, it turns out, about all or nothing, not reinforcement, no gradual, but the idea that you only sample part of reality with each trial. And both of these systems end up with exactly the same learning function. I think Guthrie is undervalued, and therefore I made this special little lecture just for him and you, and then I'll review the rest of this chapter that we'll be doing for this quiz. I'm also obsessed with the technology of cumulative recorders, as you saw me being obsessed with the technology at Pavlov, and we're going to spend time on that. So once I find my tab, I will close out this lecture. Enjoy.